Does your paper have diagonals on it?
So I've got this right here. Got two diagonals here. Let's make this a little bit bigger. At the top of this one, rectangle. What's your definition of a rectangle? Maybe you've got the correct definition in your mind, but maybe you don't. Somebody raise their hand. Tell me what you think the definition of a rectangle is. Emma, you're right in front of me, so you're the volunteer. What do you think the definition is? Good. That's the exact definition. Some people, when they come into high school, they have a middle school definition in their head where they're thinking two short sides, two long sides. And that's more of a characteristic than a definition. What's the last part of the word rectangle? Angle. What's the first letter in the word rectangle? Literally, 4 right angles. That's where the word comes from. So let's put that. This is actually the definition, 4 right angles. Everything else that we're going to add to this is merely a characteristic. So we are going to put in that we have 2 short sides, 2 long sides, and they're equal to each other, opposite sides. Let's do the same thing that we did before. We have the big picture. Big picture I'm referring to is without any diagonals. If we start throwing in diagonals, what kind of angle pairs did we say we have to consider now? What kind of angle pairs do we now have to consider? Alternate interior. So maybe that 90 gets split up into 20 degrees and 70 degrees. If that's true, then this is going to be 20 and this is going to be 70. We still have right angles here and here. What kind of triangles are showing up in this view over here? What kind of triangle is this? Didn't we just have an entire chapter on things dealing with right triangles? Did we have Pythagorean theorem, special right triangles, trigonometry, sine, cosine, and tangent? You have to consider all of that when a rectangle is being talked about. So you're not just thinking about quadrilaterals, now you're thinking about all of your chapter 7 right triangle characteristics. Maybe that's important. Maybe that will help you find pieces of the puzzle, whether you're using trig, special right triangles, or Pythagorean theorem. Dealing with the same drawing, let's put 20 degrees here, 70 degrees here, 20 here, 70 here. Does it make sense that this is also going to be 20? Does that feel right? Is the rectangle pretty symmetric? Does it look the same on the left side and the right side? This is also going to be 20. This is going to be 70. This will be 70 in this specific drawing. The reason for this is because rectangle is already a, what does that symbol mean? Parallelogram. So if a rectangle is already a parallelogram, that means that it has all of those characteristics we wrote on that other sheet. So I can do this. If it's a parallelogram, I can split up those diagonals. But those diagonals happen to be equal. Write that right below this. Diagonals are equal. That's really your extra characteristic. You've got all those different pieces that we talked about on the other sheet, the parallelogram sheet. Opposite angles are equal. Opposite sides are equal. Diagonals are bisecting each other. All of those characteristics come into play, plus the diagonals are equal. If these diagonals are equal, what kind of triangles do we have within this figure? Okay. Right. But now that I've got equal pieces in here, what kind of triangle is this? Isosceles. So someplace over here, write down isosceles triangles. So when you start seeing rectangles with two diagonals, you've got to start thinking of everything you know about isosceles triangles. You've got base angles that are equal, 70 and 70. Down here you've got 20 and 20. The top one and the bottom one are exactly the same. Triangles add up to 180, so you should be able to figure out that in this case we've got 140 and 140. This will be 40, this will be 40. A lot of things got to be running through your mind when you're looking at a rectangle situation. Maybe you'll be dealing with isosceles triangles. Maybe you'll be dealing with right triangles. You already know that this thing is a parallelogram, so it's got all of those characteristics. And then we add in the characteristic that the diagonals themselves are equal, because this is a very symmetric drawing. Turn your paper over. What kind of shape is this? What's the most specific name that you can call this? You could call it a quadrilateral. You could call it a parallelogram. But what are we going to call it? It's a rectangle. How do you know it's a rectangle? It has four right angles. So as soon as I see the four right angles, I know it's a rectangle. I know it has all of the characteristics of a parallelogram, and it's got the extra characteristic that the diagonals are exactly equal. Fill out the rest of it. If you know 42 degrees, you should be able to fill out every other little angle that's inside of this figure. You might have a quiz or a test where you have one problem. And you got to give me a paragraph proof as to how you found every single piece of that puzzle. If you know one piece, you know it all. excuse me, why am I doing this? What's my justification? Vertical angles. Why am I putting that there? What's my justification? Supplementary, linear pair. Do I have another vertical pair there? Did everybody do this? If it's a rectangle, the diagonals are equal. But it's also a parallelogram, so the diagonals cut each other in half. So all those pieces are equal, which means I have what type of triangles within this figure? Isosceles. Do isosceles triangles have equal base angles? So now whatever's left over here, I just split up. 138, you got 42 left, so this has to be 21, this has to be 21. The top one is going to be the same as the bottom one. I could look at the other isosceles triangles, or isn't this corner angle 90? What's going to be left from 90 if that's 21? 69, 69, 69, 69. I knew one angle, I know the rest because this was a rectangle. Underneath this, let's re-emphasize. Characteristic. Whenever I mention an extra characteristic, this is not a textbook term. This is not something you'll see in your workbook or your textbook. I'm referring to something beyond a parallelogram. So, extra characteristic beyond parallelogram, diagonals are equal. I'm going to refer to that term, extra characteristic. What's the extra characteristic of a rectangle? Diagonals are equal.